Okay, in this video we are going to draw the region, then use calculus to find the volume when that region is rotated around the y-axis. I will be using a computer program to create the graphs because this isn't really about graphing, it's about finding volumes. Let's go. Number 82, y equals 4 minus 1/2 x equals 0, y equals 0. So that region looks like this. It's a triangle. So we could just do this by finding the volume of a cone, but we're going to use calculus. So first up, we're going around the y-axis. This will be our radius. There's no small radius in this case. We need to invert our function. So everything needs to be y values. We need functions of y, we need dy, we need y bounds. So x is -2 quantity y minus 4, and then that means that r is -2 quantity y minus 4, because that's the only curve we're dealing with. We are going to go from y equals 0 to y equals 4. Let's set it up. So it's going to be pi, and then the integral from 0 to 4, r squared, so make sure you use a lot of parentheses there, and then dy. Now I'm just going to expand and clean up the integrand, so I'm not integrating yet. I'm going to get pi, the integral from 0 to 4 of 4, the quantity y minus 4 squared dy. I'm going to integrate, instead of expanding, I'm going to reverse the power rule on this. So I'm saying that u is y minus 4, so I'll get 1/3 u cubed. So that'll be, we still have the 4, so 4/3, and then y minus 4 cubed. We are going from 0 to 4, so now we're just going to plug in. So we get 4 pi over 3, and then we plug in 4, and you actually just get 0, and then minus, when you plug in 0, you get -4 cubed. So we have minus -4 cubed. So we have minus -64. So we have 4 pi over 3 times 64, which is 256 pi over 3. Next up, y equals 2x cubed, x is 0, x is 1, y is 0. All right, so again, same kind of deal. Here's our picture. So in this case, we are going to have two different radii that we're dealing with. We're going around the y-axis. Big radius goes all the way to the outer edge. Little radius goes to the inner edge. So we're going to need to figure out that inner edge. The outer edge is definitely just x equals 1. The inner edge, we're going to have to invert our function. So x is going to be the quantity y over 2 and then the cube root of that. Okay, so that's going to be this thing. So we are going to set this up. So our big R, we have to figure out where these intersect. I keep forgetting because I just use the calculator graph. I use graph3.com to create these. I really recommend that website. So y equals 2. We're going from y equals 0 to y equals 2. All right, here goes. Big R is just 1, right? So that's the farthest distance you go. Little r is that function that we inverted, so it's y over 2 to the 1/3. We're going to set up our integral, so we're going pi 0 to 2, big R squared minus little r squared, and then dy. So this, when we clean it up, gives us pi 0 to 2, 1 minus the quantity y over 2 to the 2/3 dy. I did this problem multiple times and got it wrong multiple times, and then I decided I should just use u substitution, so I'm going to use u substitution on this. U is y over 2, which makes 2 du equal dy. By the way, the reason that I knew that I was getting it wrong was that the answer was just wildly complicated, and I was like, there's no way that this is right. So finally I did this, and it worked out much better. No matter how good you think you are, sometimes you just got to go back to u substitution. So if y is equal to 2, u is equal to 1. If y is equal to 0, u is equal to 0. Completely rewrite. So we'll have pi, we get a 2 from our du, or dy is 2 du. Now we're going from 0 to 1, and it's 1 minus u to the 2/3 du. We're going to integrate, so we get 2 pi, the quantity, the integral of 1 is going to be u, and then plus 1 times the reciprocal gives us 3/5 u to the 5/3 from 0 to 1. When we plug in here, plugging in 0 zeros it out, so plugging in 1 is really all we need to do. 2 pi, quantity 1 minus 3/5, which gives us 4 pi over 5. As I mentioned before, I did this a whole bunch of times and got it wrong. U substitution is the way to go. It's just cleaner, makes the problem easier to do. I don't know what I was doing wrong, and I never managed to figure that out, so that's great. New problem. So y is 3x squared, x is 0, and y is 3. Let's look at the region. So it looks like this. So I like to graph when it's y equals, and then I will invert from there, just in case you're wondering how I would graph these by hand. I'm going to graph y equals 3x squared. I'm not going to graph the inverse of that. Okay, so going around the y-axis, we got our big radius, and that is all. We are going to need to invert, so divide by 3, take the square root. We want the positive square root because we're to the right of the y-axis. In general, with these problems, that's pretty much what happens. If we were to the left, we would take the negative, but you don't see that in problems very often. You probably should see it more. We're going to be going from y equals 0 up to y equals 3. Let's write down r, which is just our function. And then we're going to go pi, the integral from 0 to 3. We need to square r, so it's r squared, and then dy. We can clean up the integrand. It cleans up really nicely in this case, right? We just get y over 3. So now we're going to integrate. So it's going to be pi. I'm going to pull out the 1/3 and then do plus 1 times the reciprocal. So 1/2 y to the second. And we're still going from 0 to 3. So when we plug in 3, we're going to get 9. When we plug in 0, we're going to get 0. And there's a pi over 6. So 9 minus 0. So that is 9 over 6 is 3 pi over 2. All right, next. Y is the square root of 4 minus x squared. Y equals 0, x equals 0. Square root of 4 minus x squared is a semicircle. So this is weird, and books do this all the time. Like this region, if we rotated around the the y-axis rather, because that's what we're doing, like what happens? It's like you're doubling things. So really what I'm going to do is just restrict myself to the first quadrant, right? Like you kind of have to choose, right? The first or the second quadrant both satisfy this description. So I'm going to go with the first quadrant and do the normal thing that I would do. So there's big R. We are going from 0 to 2. We're going to need to invert this. So square both sides. And then I like to add x squared, subtract y squared. So that'll give me x squared is 4 minus y squared. Take the square root. So x is the square root of 4 minus y squared. Okay. So now we will say that big R is just that function that we just found, square root of 4 minus y squared. Our bounds are 0 to 2, so we can set this up. It's going to be pi, the integral from 0 to 2, big R squared, so square root and then squared, that's really nice, dy. Clean up the integrand, so pi 0 to 2, just 4 minus y squared dy. Now we're going to go through and just reverse the power rule, like the whole way through. So you're going to get 4y and then minus 1/3 y cubed. We are going from 0 to 2. And then when we plug in 0, everything goes away. So really it's just 2 that matters. When you plug in 2, you're going to get 8 minus 8/3. And then there's still like that minus 0. I like to put that in because, you know, you want to make sure that when you look at your work, you know that you did the right thing. And then 8 minus 8/3 is 24 minus 8 over 3, 16 pi over 3. All right, next problem. I should point out, like this is just going to give you half of a sphere. So the volume of a sphere is 4/3 pi r cubed. So it would have been this, and then we just get half of it. So you can check that one geometrically. Always a good idea. All right. Y equals 1 over the square root of x plus 1, x is 0 to x is 3. Let's look at the region. Kind of looks like this. Would I struggle to graph 1 over the square root of x plus 1 by hand? Kind of a little bit, but like what I would do is I would just graph x equals 0, x equals 3, and then just put a function above them because it doesn't really matter what it looks like all that much. You do want to be accurate, but like when you're limited, just set it up the best you can. You know that 1 over the square root of x plus 1 is positive, right? So it would have to be in the first quadrant. All right, let's see. So this is a little complicated. We're going around the y-axis. I'm going to have to slice this into 2 regions and do 2 volumes and add them up. So we'll have a big R, which is just x equals 3. And then we have 2 big R's, I should say. We have an R1 and an R2. R2, we need to do some math to figure out what it is. So take reciprocals, square both sides, subtract 1. We get x is 1 over y squared minus 1. Okay, so we also kind of need to know definitely need to know where these intersect. So if y is 1 over the square root of x plus 1 and x is 3, then we get 1 over the square root of 4, which is 1/2. All right, so this line here is 1/2, which you can visually see, but if you're not using a computer to graph it, can you visually see? I don't know. Okay, so R1 is just x equals 3. R2 is the thing that we found, 1 over y squared minus 1. We're going to set up two integrals, do them both, add the result. That's the plan. So pi 0 to 1/2 of r1 squared plus pi from 1/2 to 1 of r2 squared. So quantity 1 minus y squared minus 1 squared. 1 over y squared minus 1 squared? I don't know what I even said. dy. All right, so let's just clean up integrands. Obviously 3 squared is 9. When you square 1 over y squared minus 1, you're going to get like 1 over y to the 4th. Multiply them together times 2, so negative 2 over y squared, and then plus 1. But I chose to write it all with negative exponents because it's easier to integrate from there. So that's what I've done. I'm going to just go through and integrate. So we get pi times 9y from 0 to 1/2, pi, and then it's plus 1 times the reciprocal, plus 1 times the reciprocal, and then the integral of 1 is y from 1/2 to 1. Fundamental theorem, this thing. It's gross. So, the first part's not bad. You just get 9 pi over 2. Then you get pi. When you plug in 1, you get negative 1/3 plus 2 plus 1. When you plug in 1/2, you end up with like 3 over 8, but then the reciprocal, so negative 8/3. And then you have 2 over 1/2, which is 4, and then you have just 1/2. I use a calculator to clean this up. I got 16 pi over 3, which I think is right. If it's not, let me know. Let's take a look at the next one. I think there's 3 more, including this one. X is secant of y, which without the calculator, I'm not sure I would have known what it looked like. Y is pi over 4, y is 0, x is 0. I do think it's important when you're doing these to realize, there's nothing wrong with helping yourself with a calculator sometimes or a graph or whatever. If you don't know how to start a problem, you're never going to be able to practice. So, don't let that stop you. I didn't let that stop me here. Try not to let that stop you. All right, so x is secant of y is pi over 4, y is 0, x is 0. That's our graph. We're going around the y-axis, so there's just big R in this case. This problem's actually easier than it seems, maybe, because of that x equals secant is a little bit weird. So we're going to go from, we were given pi over 4, and obviously we're starting at 0. So our integral, big R, or just R, the only thing we have, is secant of y. So we'll set it up. Pi, the integral from 0 to pi over 4, r squared, so we get secant squared of y dy, but secant squared is one that we have memorized. That's the derivative of tangent, so this is going to kind of go well for us, I think. So we get tangent from 0 to pi over 4. Fundamental theorem on this gives us pi, tan of pi over 4 minus tan of 0. Tangent of pi over 4 is 1. Tangent of 0 is 0. You got to have those memorized. We use those. We just get pi as our answer. So that one, although I don't think I would have known what to graph to start with, I still would have just set up the same integral because in the absence of knowing what the graph is, what else are you going to do, right? You're going around the y-axis, you have x equals something, that's probably r. All right, next up. Y equals 1 over x plus 1, x is 0, x is 2. I should mention these all come from the OpenStax textbook, which I will link in the description below. Highly recommend it. It's a great source of problems. Here's our graph. We're going to have to split this again, like we've done on previous problems. We're going to have just 2 big R's, though. There's no little r's involved. So we do need to figure out, what is the coordinate of that, right? So it's if y is 1 over x plus 1 and x is 2, then it's 1 over 2 plus 1, or 1/3. So that's just the equation of this line. So that's where we'll split our integrals. First big R is just x equals 2. Second big R, we're going to have to invert this function. So take reciprocals, subtract 1, we get this. Let's set up some integrals. So big R1 is 2, big R2 is 1 over y minus 1. So we're going to go pi from 0 to 1/3, because it's all the y values, big R, which is 2 squared dy, plus pi from 1/3 to 1, big R2, which is 1 over y minus 1 squared dy. All right, so let's expand some stuff. So we'll get pi 0 to 1/3 of 4. That one's pretty set in stone. Plus pi 1/3 to 1. When you expand this, it's like you get 1 over y squared, which is y to the negative second, minus 2 over y, which is negative 2 y to the negative first, which I kind of regret writing that way because 2 over y is a little easier in your mind to integrate than 2y to the negative first, but we'll deal with it. And then plus 1. All right, we got to integrate. So you get 4 pi times y from 0 to 1/3, straightforward. You get pi plus 1 times the reciprocal is negative y to the negative first. Then here we get negative 2 natural log of the absolute value of y, because the integral of 1 over y is going to be the natural log of the absolute value of y. And then plus y. We're going from 1/3 to 1. So first part's easy, just get 4 pi over 3. Second part, you just got to like write it all down. So you're going to have negative 1 minus 2 natural log of 1. Natural log of 1 is 0, and then plus 1. So you have negative 1 minus 0 plus 1. You just get 0 for that part, which is great. Minus, when you plug in 1/3, you get negative 3 minus 2 natural log of 1/3 plus 1/3, which is a little messy. So overall, because of that 0, we get 4 pi over 3 plus pi. Distribute the negative gives you have 3 minus 1/3 is 8/3, and then 2 natural log of 1/3, which like cleans up a little to 4 pi plus 2 pi natural log of 1/3, but like, is that a useful cleanup? I don't know. All right, we got one more. Y equals 4 minus x, y equals x equals 0. Here's what it looks like. We have to divide it. So we're going to divide it at 2, you can see visually, but if you're not sure about that, you just work it out, right? Set them equal. 4 minus x equals x, which means that x equals 2. And if x is 2, that means that y is 2 because y equals x. So we are going to split it at y equals 2. We need to invert both of these. So like x equals 4 minus y. And then also, I like to rewrite this because I don't like y equals x when I'm dealing with x equals a function of y type situations. And we can set them up and do them. So let's do that. So there's big R1, there's big R2. Big R1 is our x equals y function, so just y. Big R2 is our 4 minus y, so there we go. We get pi, we're going from 0 to 2 of R1 squared, which is just that, plus pi from 2 to 4 of R2 squared, so quantity 4 minus y squared dy. Sometimes I deal with that by reversing the power rule, like reversing the chain rule, reverse the power rule. In this case, I just expanded it. I don't know which one is easier. So pi of y squared from 0 to 2, and then pi of 16 minus 8y plus y squared from 2 to 4. We have to integrate, so it's just all reversing the power rule. So literally just reverse the power rule all the way through. Fundamental theorem gives us just 8 pi over 3 on the first part. Got to actually show some work on the second part. So when we plug in 4, we're going to get 64 minus 64 plus 64 over 3. A lot of 64 things. Minus, when we plug in 2, we get 32 minus 16 plus 8/3. Clean it up. We end up with 8 pi over 3 plus pi times the quantity 64/3 minus 48/3 minus 8/3. And then overall, 16 pi over 3. All right, so those are a lot of examples of going around the y-axis. I hope you found this helpful, and good luck.